Hi all. In this video, we are going to use example of Terminator movies for educational purpose and map real-world system design principles into fictional AI movie and thereby understand and learn how to build system that scale like Skynet. First, let's see what is Skynet. Skynet is a fictional AI system from the Terminator movies, originally built to automate military decisions. It became self-aware and decided humanity was a threat. It launched a nuclear war and unleashed an army of killer robots, including the iconic Terminator, to wipe humans out. But behind this sci fi chaos is a system that was incredibly well designed, globally distributed, resilient, and always online. Let's break down how Skynet could use load balancers, distributed database, and messaging queues to run like the most advanced tech company ever. It wasn't just a powerful, it was built to survive failures, reroute traffic, and process massive amounts of data in real time. In this video, we are going to discuss various concepts like high availability, consistency, cache, load balancer, database sharding, auto scaling, monitoring, rate limiting, disaster recovery, messaging queues, DNS, and CDN. So let's see what is availability. In a system design, high availability means the system keeps running even if some parts fail. The T800 or Arnold's Terminator is highly available even when damaged, shot, burned, or misses an arm. It keeps functioning. Just like distributed system replicates service across multiple servers to prevent downtime, the T800 has redundant critical systems like backup power, alternative vision mode, etc. to ensure it doesn't fail. The second concept is consistency. CAP theorem states that in a distributed system, you can't have consistency, availability, and partition tolerance all at once. You must choose two. The Terminator syncs information from the future but operates in the past. However, it sometimes gets out of sync when events changes, like John Connor's survival. If he prioritized consistency, he would have to pause every action to confirm that the future still matches with his mission parameters. Instead, he prioritizes availability and partition tolerance by continuing his mission even if data is incomplete or changing. The next concept is CDN or Content Delivery Network. A CDN caches data at edge locations to ensure fast access across the world. Skynet doesn't sense just one Terminator. It deploys multiple models such as T800, T1000, TX, etc. across multiple timelines and locations to cache and kill orders near its targets. Instead of waiting for a single Terminator to travel long distances, that is high latency, Skynet distributes the load across multiple units, reducing response time and increasing efficiency. The next concept is domain name system. TNS helps map human readable domain names to machine relatable IP addresses. The Terminator doesn't know Sarah Connor's exact address immediately, so it queries a directory, a phone book, to resolve Sarah Connors into an actionable target address. Just like how DNS routes users to correct IP, the Terminator resolves high level query into an exact physical location. The next concept which we can understand is distributed messaging queue. In distributed systems, a message queue ensures tasks are processed in the correct order. Skynet can't process everything at once, so it queues multiple orders, like terminate Sarah Connor, terminate John Connor, and deploy another Terminator, etc. These tasks get distributed across different Terminators or workers, ensuring they don't all overload one execution unit. Think of T1000 and T800 working in parallel. One handles direct attacks while other infiltrates. The next concept which we should understand is load balancer. A load balancer distributes incoming requests across multiple servers to prevent overload. Skynet doesn't send just one Terminator to eliminate John Connor. It distributes the load among multiple units. Example, in Terminator 2, the T-800 fights while John Connor runs, dividing the task between combat and protection. In Dark Fate, multiple machines are sent across different locations to ensure mission success. Next, database and sharding. Sharding basically breaks a large database into smaller pieces, distributing them across multiple nodes. Skynet doesn't rely on single brain or single node. It's a distributed AI, meaning parts of its intelligence exist in multiple locations. In Terminator Salvation, John Connor destroys one Skynet base, but AI keeps running from other locations, proving it's not dependent on a single system. Example of sharding can be one Terminator stores targeting data, another one stores combat tactics, another manages strategic decision making. If one is destroyed, Skynet still functions because the system is partitioned across different locations. Next concept is horizontal and vertical scaling. Vertical scaling basically means scaling up, that is, making a single Terminator stronger. Example, upgrading the T-800 to the T-1000, which has liquid metal, making it more powerful but a single unit. On the other hand, horizontal scaling means scaling out, that is, deploying more Terminators. Example, instead of just one T-800, Skynet sends an army of machines like TX models or drones to distribute the load. This ensures high availability because even if one Terminator is destroyed, the mission continues. The next concept is monitoring and observability. A monitoring system ensures performance and detect failures in real time. Skynet constantly monitors the status of its Terminators, updating strategies based on failure reports. Example, in Terminator 2, the T-1000 scans environment, check heat signature, and analyzes damage level, just like monitoring tool that collects log and metrics. If a Terminator stops responding, Skynet knows it failed and it deploys a replacement using auto-scaling mechanism. The next concept is rate limiting. Rate limiting basically controls the number of requests a system can handle to prevent overload. Imagine if Skynet sends 1,000 Terminators at once to kill John Connor. This would be wasteful and raise suspicion. Instead, it sends one or two at a time, ensuring the mission remains stealthy while avoiding excessive resource usages. The T-1000 doesn't attack constantly. It paces itself strategically like a system enforcing request throttling. Next concept is disaster recovery. In distributed system, disaster recovery (DR) ensures that system can recover from failure. Skynet never assumes a single failure is final. It has backup. Like T100, if failed, it deploys T1000. If T1000 fails, it deploys TX. If fails again, then AI-driven full-scale war is done, which is in Terminator Salvation. The next concept is failover mechanism. Failover ensures that when a system component fails, another takes over automatically. When T-800 is destroyed in Terminator 2, John Connor immediately switches protection to Sarah Connor, like an active passive failover system. Skynet itself has failover mechanism. If one machine stops responding, another instantly picks up the task. If a T-800 is damaged, it switches to alternative modes, limping, using one arm, etc. Next concept is edge computing. Edge computing moves processing closer to the user to reduce latency. Skynet can't rely on central servers all the time due to possible attacks. So terminators are designed to operate autonomously when disconnected. Example is when T-800 doesn't need to communicate with Skynet. It learns and adapts locally. These are the primary concepts which we can understand with help of Skynet. In conclusion, we can say the Terminator universe is a goldmine of system design analogies. Skynet is essentially a decentralized self-healing, auto-tolerant AI designed with high availability, like multiple terminators, scalability, like upgrading a T800 to T1000, monitoring and observability, analyzing mission status, scanning heat signatures, etc. And finally, disaster recovery and failover, that is sending new models if previous one fails. With these examples, we will be able to understand system design in a better way and implement them. That's all for this video. Thanks.